Now I will start quiz 9. First, the main ideas of the today's question are MN's properties and how many voters should be sampled in specific situation. Here is the solution. This green circle means given population, and P means the probability of voters supporting a candidate A among the given population. N means the number of the voters who randomly selected and interviewed among the given population. Last, Mn means the probability of voters who support candidate A among N voters. And we can think of Mn as estimate of P. Now let's see the properties of Mn. First, the reply of each voters interviewed is Bernoulli random variable, because the reply has to be two things, yes or no, and yes means he or she support candidate A, and no is the opposite. And Mn can express like this. Also, Mn is the estimate of P. So, Bernoulli random variable X has success probability P and variance P multiply 1 minus P. Then, by Chebyshev inequality, we can get this formula, and when X is known to take value of 0 and 1, we claim that variance like this. Variance is this, so we can fix the formula like this. To know about mean of this formula, let's take an example. If epsilon is 0.1 and n is 100, we obtain this formula. It means that when the sample size of n is 100, the probability that our Mn, in here M100, is incorrect by more than 0.1 is no larger than 0.25. Now, suppose that there are some tight specification on this pole. This is the specification. This means that Mn will be very accurate within 0.01 of P, and this means the probability of inaccuracy below 0.01 should be less than 0.05. In words, at least it has to be get 95% of accuracy. In this situation, how many voters should be sampled? If put the given values in the formula, and calculate like this, we gain the range of n values. As a result, at least 50,000 voters must be selected to satisfy the specification. But because it is based on the Lerelus-Chebyshev inequality, the value turns out to be fairly conservative. Thank you for listening.